Hi guys, welcome to other video of Matrices introduction. So I have already discussed a few theoretical and important topics in the previous video, and I don't want to make that as a very lengthier video, so I'm just splitting into two halves. That first part is considered as introduction 1. I'll edit that and update that, and this is part 2. After these two parts, we'll start with the concepts which deal with the problems. Okay, so all these concepts we will be using in the problems, and for every problem, for every concept, I'll explain you with an example over there. And after completing all the topics, I will also try to make videos on few previous paper questions, so that you will be understanding like how you will get questions in the exam and how you have to write the answers for it. Okay, so in this video we'll just see what is minor of a matrix. Okay, so all these definitions you have to write on your own, or you can just go with all these definitions whatever I have written here, and I won't be explaining you in a definition way. I'll just explain you the concept here again, just as the previous video. So what is minor of matrix means, if you consider a matrix, if whatever the given matrix, and if you take a part of it, that means if you take a sub matrix, okay, that means you will not be using the complete matrix, but just like 2 rows or 2 columns, 3 rows, 2 columns, like that. So that is known as sub matrix. Okay, then what is minor? If we find det, okay, I have already explained you that we will use det in many ways in this matrices. So here I'll tell you how to do the det. Also I'll be explaining you this det concept in the problems again. So first, this is the sub matrix. Okay, I have taken this matrix 2 1 3 1, right? Sub matrix means what? A part of the given matrix or original matrix. Now, of what order I have taken? Order means what? Number of rows and columns we'll write here, right? N cross n, that is known as order of matrix, right? So order is 2 because we have taken 2 rows and 2 columns. Now if we find the det of this matrix, then we say that whatever the result we got, that is the minor of order 2 matrix. Okay, order 2 matrix. Guys, if you don't know what is order, please go through the first video again and then come here. Okay, so how to find det means, okay, you have taken this matrix, right? So you have to cross multiply the values, and then you have to subtract them. Okay, first 2 into 1, cross diagonally you have to multiply, all right, and then you have to subtract the value, minus 3 into 1. Whatever the result we get, that is the det of this matrix. That is how you will find. Next, I have taken the matrix order of 3, that means 3 rows and 3 columns. Okay, so here order m cross n is 3. Okay, here for the 2 we have just multiplied and then subtracted the values. Then what about the 3 order means? For this, hold this value, that means det. I am explaining you det again. Okay, det c 2, it should be multiplied into 1 into 7 is 7, minus 6 2s are 12. Okay, we have completed the minor for this value. Okay, and then minus 1 into, we are taking this column and this row, right? So we have to multiply the other values. Did you understand? See, if you are taking this value, we should leave this complete column and complete row and then multiply the other values. Similarly, if you are multiplying this value, for this value you have to leave this column and the row. So if you leave this column and the row, you will get 3 into 7 21, minus 5 2s are 10. Okay, and now you have to take place. Again, one more thing, many of you will get doubt, like here I took minus, here I took plus, because the order is like that. So once if you take plus, you have to take minus, again plus, if you have any, you have to take minus. Okay, plus minus, it should be alternate, right? And now again you have to take this number. If you are taking this number means you have to leave this column and this row. So what the numbers will be? 3, 1, 5, 6. Okay. So 1 into, I forgot to put 1 here. 3 6 are 18, minus 5 into 1 is 5. So how you will solve mathematically, the simplification is still the same. Okay. You will get the answer, that is the det of the matrix C, which is of order 3. Okay, this det will be easy for the order 2 matrix, and a bit confusing you'll get when you're dealing with it first time. So make sure that you listen to this process again and again, and if you are not clear with the thing which I have explained, you can just go with many other videos you'll have in YouTube. But in the end, what you have to make sure is you have to understand the det concept first and then go with the problems or any other thing, because if you don't understand this, you will not be able to solve any of the concepts. So if I'm not able to make you understand clearly, please mention in the comments, so that I'll just make a separate video for this det concept, and meanwhile you can go through the other channel videos. Okay, now let's see properties of trace of matrix. We have already seen what is the trace of matrix, right? Sum of the diagonal elements. So if this is the matrix, for example, so sum of 2 and 5 4 is trace of the matrix. So for that we have few properties. So you won't get any questions related to that, but you will use these properties very rarely for this syllabus, I suppose, but generally you just read these properties. And then idempotent. So this means when a matrix is squared, okay, then the answer will be again the original matrix only. Then it is called as idempotent matrix. That means A square equal to A. This is A matrix, right? If I multiply A matrix with again A matrix, then the answer will be again A only. Okay, if that condition is satisfied, then we say it as idempotent matrix. I'll write it clearly. Multiplied, you will get the same answer again. I'll show you how to multiply the matrices again using calci and by hand also. For now, just remember the conditions. Okay, when you get to know how to multiply all these things, then you will understand all these conditions very clearly. And now we'll see involutory matrix. So what is involutory matrix means? See, in the idempotent, if A square equal to the A, that means original matrix, then it is idempotent. If A square equal to I means what? Identity matrix. That means all elements will be 0 except the diagonal elements. Okay. So, if you get A square as I, then it is called as involutory matrix. I suppose I'll write it here into. So if you do this, then your answer should be what? The same I matrix. That means identity matrix. So I have already discussed this identity matrix in the previous video. So please go through it again if you have any doubts. And identity matrix is what you'll have diagonal elements as 1 and all the other elements as 0, right? And nilpotent matrix, it's a square matrix. I mean, a square matrix is said to be a, this is important, nilpotent matrix when a power n is 0. Okay, here n can be any index. That means if you are performing a square, a cube, a power 4, a power 5, something like that for the given matrix, if at all a power 6 you got all the elements as 0, then that matrix is called as nilpotent matrix. Okay, you will say a power 6 equal to 0, so the given matrix is nilpotent matrix. You will get a question for this, like what is nilpotent matrix, and check whether the given matrix is nilpotent matrix or not. Then what you will do, see, the condition is a power n equal to 0, you don't know what that n is. In such cases, what you have to do, you have to do a power 1, a power 2, a power 3, a power 4, a power 5, 6, and until you get the 0. Okay, mostly you will get by a power 6 or something like that. You'll, that many iterations it won't take. So then you have to make sure that, okay, the given matrix is the given nilpotent matrix. Why? Because a power something is 0. Okay, this is important. You might get question for 2 or 3 marks. And the transpose of matrix, transpose, okay, transpose of the matrix means it is the matrix obtained by interchanging the positions of rows and columns. That means the given matrix is this. If you have to write all the row as column elements, all the columns as row elements. That means first row will be first column will be first row. Right? I guess I confused you here. Let's see with the example. So this is given matrix, right? A 1 3 2 4. Now what is the A transpose? So take the first row 1 2. You have to write it in a column way. Okay? And take the first column, write it as row. All the elements then eventually will get aligned. Okay? You don't have to do the transpose for the second row for the order 2 matrix. Okay, for order 3 again it will be different as in you have to write all the rows as columns as rows. Columns as rows, like if you take 1 2 3 4 5 6 7 8 sorry 7 8 9, how you will write? I'm taking first row, so I'll write it as, just follow one thing. Okay, I'll take first row, I'll write it as column. I'll take second row, I'll write it as column. Sorry if the video isn't visible to you. Okay. I'll take the third row, I'll write it as column again. So this is interchange. So you don't have to take, I have written this column, row, right? So then I have to write it the column here, so it will be automatically adjusted. Okay, take only one thing, so I'll take always rows. Okay, if I'll take first row, I'll write it as first column. I'll take second row, I'll write it as second column. That way will be easier. Okay, now properties of transpose of matrix. So remember all these properties. We don't have to prove all these properties using theorems. Just remember this because we will be using in the problems. Okay, A transpose whole transpose is A plus B whole transpose is A transpose plus B transpose. Again, if A something written as a T means transpose. Okay, that is the denotation. How you denote? K into A whole transpose is K A transpose. Here K is integer. Okay, integer. And then AB whole transpose is B transpose A transpose. These are the important properties. Please try to memorize these 4 properties. And now symmetric matrix. So symmetric matrix means a particular matrix is said to be symmetric if A transpose, right? A transpose is also A. That means if you write rows as columns as rows, still you should get the same matrix. Then it is symmetric. Okay, this is important concept, very important concept. Okay, see, for example, this is the given matrix A. Now I'll write this transpose for this. If I write the transpose matrix, you should get the same again. Then it is called as symmetric matrix. I'll write transpose here. I'll take first row, write it as first column. Then take second row, write it as second column. Take third row, write it as third column. Now check whether both matrices are same. Yes. Okay. So this matrix is said to be symmetric matrix. Definitely you will get the question in 2 marks or 3 marks. Sometimes you might get in the 5 marks question also. Okay. So they'll give set of matrices and ask you to find the symmetric matrices, or they will give the matrix and then they'll ask you to find the symmetric matrix for the given matrix and write the complete procedure, and those matrices will not be simple. Okay, procedure is still the same, but there will be few theorems related to this symmetric matrix and skew symmetric matrix, which is right here. So using these theorem concepts and the given matrix, you should find the alternative symmetric matrix. You will, I guess it will be confusion for you now if I tell you all these things, but I am just telling you what kind of questions you will get in the exam along with the explanation. And skew symmetric matrix. So here what in symmetric, A transpose should be equal to A. In skew symmetric, A transpose should be equal to minus A. Alright. So whatever the elements we have previously, for all those elements you will get minus. Okay, I mean position differs. See, this is the given matrix. Write the A transpose for the given matrix. I am writing for this only. Now I'll take first row, write it as first column. Second row, second column. Third row, third column. Yeah. Now how you will say this is minus A? Previously we have A here. Now we got minus A. Previously we got minus A here. Here it's A. That means that positions are interchanging. So what I'll take minus common outside. So 0 A. You will get minus B, right, if you take minus common. Again here we don't have, so you have to write minus A. 0 is 0, no sign. And C. Then what you have to write? B minus C and then 0. Why I have written minus outside? Because see, if you multiply minus into 0, it's still 0. Minus into A, minus A, whatever it is here in the A transpose. Minus into minus B is plus B. Okay, I suppose you know how to take the minus out and fix it with other elements. So I have write minus here. Okay, so I have taken minus here outside, and if you observe this complete matrix, it is what? Given A. So I write A, substitute A. So what the answer? Minus A. Okay, this is how you prove that the particular matrix is skew symmetric again. Okay, and also if you don't know how to take common and how to write the minus and plus for all the other elements in the matrix, just please comment down in the for this video or any other video. I'll just explain how to take this common and just post a small video for this thing. Okay, it's very simple. If you take a minus common, you have to add the minus for the values which don't have minus previous, and you have to remove the minus for the values which have minus, so that when you multiply you will get the same results. Okay, yeah, and that's all for this video. I guess all the conceptual part, that means introduction, definitions, all these are done for the matrices chapter. And from next video I'll explain you theorems and related problems. And also we will see few, sometimes I'll take few previous years exam question paper and then take those questions as examples. Okay. And if you have any doubts at any point of time during the video, please feel free to uh, tell me what the problem you are facing with. If at all I explain something wrongly, please feel free to post that as well, and I'll rectify it myself, and then I'll post new video again if there are such kind of things. And make sure that you understand the concepts of matrices very clearly, because you'll get more questions from this chapter which are easy questions. You have to know the procedure clearly. So while listening to all those videos and by seeing sums, you will definitely say that okay, I can do all these sums. But when it comes to exam, when writing the exam, if you don't practice all these matrices, then definitely you will not be able to write there, and that's guaranteed. Okay, you have to practice on your own. You have to take the calci, you have to practice every matrix sum, only then you will be able to do it in the exam. Because the matrices are, to see, they are very easy, but while doing you'll get many calculations, mistakes, all such kind of things. So make sure you practice this chapter very clearly. Okay, I'm saying this because I have seen many who did not practice, but they know all the concepts and how to do the procedure, but they failed to do it in the exam. So that's why. Okay, thank you.